This is, I don't know, I've lost count how many times I've started this video. So I have a cheat sheet with some notes, so bear with me as I work through this. This is going to be the first video of the design and construct that I've been promising to share with everyone. I thought I'd start off with a little bit of history about myself. I've been riding for 40 years. I've raced everything from road to track to cyclocross and now gravel, BMX, mountain bike, cross country, enduro, downhill. I've never done trials or bike polo or anything like that. I have worked as a bicycle messenger in Sydney. I've worked as a sales and also as a mechanic in bike shops in Brisbane, and I've been working for 35 years as a design draftsman in heavy industry, which I still do today, as well as building the bikes. So that's me in a nutshell. I have a couple of state cross-country medals to my name, quite a few club race wins, and both road and mountain bike, and that's about it. So never been complete elite level, but been pretty handy at times. So been building frames now for 11 years, and the mountain bike frames for 5 years. The first one being the Ocean trail bike. These videos, or what I'm going to explain, will be just the Jester platform and the specifics to that. The Ocean is very similar. It's basically a short travel version of the Jester. It shares the same philosophy that I have for the Jester, because the Jester came from the Ocean. The road and gravel bikes are an individual build. They're full custom, and they share a similar process in terms of design and construct, but they're very specific in those ways. So where do we start? My design philosophy for bikes in general is that they are to be well mannered and quite neutral in handling. I have ridden bikes, both slow handling and fast handling. They're very generic terms, and there's a lot that goes into how a bike handles and how it reacts to rider inputs, and the industry and everyone keeps throwing out all these generic terms, and there's a lot of nuance to it. So, but putting it in a simple explanation, my bikes are neutral handling and of a style that some describe as self-riding. So the idea being that when you're fatigued, or if you're riding really fast at your limit through chunky terrain, the bike's not going to react badly to your input. You're going to know with confidence how the bike's going to react to a situation, so you can commit to, say on the Jester, to some pretty wild lines, and knowing how the bike's going to react to that. So it allows you to carry more speed and be more confident and get off the brakes more. So in a racing sense, you're going to get faster times, and in a general trail riding sense, you're going to use less energy. You're just going to have more fun. And like, for most of us, the success of our riding is on how big our smile is on our face. So that's what I shoot for. So with that in mind, I'm rambling on a little bit. The design process is complicated. There's a lot of backwards and forwards. You start with some numbers and some ideas, and then you jump to sort of looking at parts, and there's a lot of distractions, so it's quite easy to get lost in it. One of the first things I did when I was designing the Ocean was to go and watch YouTube till the cows come home, talk to suspension experts, both in tuning and even emailing some of the companies, reading all the articles I could find, looking at other areas like motorcycle suspension, design and stuff like that, to just try and get my head around what people were talking about and try and get a feel for just idiosyncrasies of it. So if I make a change to some dimensions or to some aspect of it, I've got at least a chance of understanding where that's going to lead me. So in looking at all the different platforms with suspension, I kept coming back to the 4-bar horse link. It's quite simple to understand in how it works, which makes it a lot easier to then tune the performance of, and it's a proven platform. There's lots of brands that are still using it. There's other suspension platforms like the original DW, which the patent has run out of, and you don't see a lot of people clamoring to use it all of a sudden. So the 4-bar horse link, it's a mainstay, and I'm glad that I did choose it and go with it. It's proven to be an excellent system to design and tune for, so it'll be a system that I will continue with for all my bikes until I see a need to change. So with that in mind, I had some ideas of some general set out numbers that I wanted to work to, that I felt like was going to give me the bike that I wanted, especially with the Osheen when I first started. So with that in mind, there's a program called Linkage, which allows you to plot all the points of the suspension and then move them around, and it then creates graphs that you can then extrapolate information from. So I ended up playing around, like especially with this area here in the design in the middle. This has a huge effect on how the suspension works. And also this section, there's the rear axle and what they call the horse pivot, for those who aren't familiar with it. That mostly has an effect on the braking characteristics of the bike. I run a fairly low, flat, what they call an anti-rise number. As you can see there, it's quite flat in its operation. I can't seem to get it any flatter than that. So, but it's centering on about 64% across the travel range. So the leverage ratio for the new Jester, the latest variation, starts at 3 to 1, and runs down to about 2.35. So that gives a nice progression. You can run a shock, a coil or an air shock on that. And then also the other big one that everyone talks about is the anti-squat. So at SAG, it's around 107%, 108%. And that differs. Like for a trail bike, I would run that number a little bit higher, but for more of an enduro race bike, it's still going to give good sprinting out of the corner, but it also allows, sort of starting to allow a bit more of a supple suspension, a little bit more reactive again when you're pedaling. So it's a really fine balance, and there's always a compromise. Like you can go too far, but there's always trying to sort of balance these characteristics against each other to get to this little envelope that you're going to be happy with. So that, when I first designed the first bike, that was more of a guess, really. I could go off what other brands and sort of have a look at their bikes and borrow some layouts and get a feel for it, but in the end I had to come up with a decision, and I just got some numbers that I felt were good, and then went from there, made the first bike. And fortunately they've proved all that time and research, like probably put 1,000 hours of research into the design of the first bike. I pretty much hit the ground running with that one. That was really satisfying, and all my bikes have followed that general formula, for want of a better word, of my platform. So the Jester then became a longer travel version of the Ocean. I've tweaked it slightly. I brought the leverage ratio of the rocker system down to reduce the pressure in the air shocks. Makes for a slightly more supple starting stroke, and it seems to be working really well. I'm really happy with how that feels. On my bike, I've designed them mostly around an air shock. I'm going to be running the Öhlins coil once I get that custom tune from NSR Racing done for it. And that'll be really fun to run a coil. I've never run a coil, so that'll be really good. So, no, I'm ranting a bit. So I ended up with the linkage. So and that spits out a whole bunch of dimensions in the menu here, which you can then, what I ended up then doing was transposing those dimensions into AutoCAD. So I use AutoCAD. There's Fusion 360. There's 1,000 CAD programs on the market these days. So I use AutoCAD because that's what I use mostly in my career job, and I'm very familiar with it. And since modeling the mountain bike stuff, especially the 3D part of it, I've become very proficient at modeling this. I'm still learning stuff today though, so it's a good, easy program to use. It does have its limits, and I'm bouncing on those limits all the time, and I'd have to figure out workarounds, but that's the same with any CAD program. So what happens is I transpose those points, which you might be able to see in magenta on the screen. So they're the static unloaded points transposed over from the linkage program. And then in this, I can then run that shape, run this rocker and everything through its range of movement, and I can plot the starting point and the ending point for the rocker and the swing arm. And what that allows me to do then is I can get the shape of the wheel, and I can check it against the shape of the frame to make sure I'm not getting any clashing with the wheel. I've oversized that a little bit, so I've got a margin, and it's like, I guess, a safety factor. So that allows me to do that. Once I've laid that out, I will plot where I want my front wheel to be. I'll plot the offset that I want for my fork, the axle to crown height on the fork, the head angle, where my center of my seat's going to be. So all those things get plugged in. There's a lot more to it than just that. It's not just simply just mark. There's a lot of thinking going on. So one of the things is you need to interface with a lot of parts. So you've got bearings, you've got the fork, you've got the shock, even the bottle cage, the seat, like all those parts that get bolted onto a frame, you need to interface with them, and they have working envelopes. So you need to know clearances and sizing, all those sorts of things. So, and they're not all the same. There are a really good solid central set of specifications. People like to call them standards, but they're not. They're just specifications. They become standard use though. Things like the headset bearings, where your cranks spin through, all those sort of things. So they get plugged into the model. So here I've got the fork, bottle cage, the shock. This is the 8 pins integrated seat post, which I used on my recent frame. Put the disc and the UDH, and I did have a disc rear brake caliper in the model, but I've deleted it out for some reason, so that's okay. I don't need that in there now. So I put those into the model. This one's actually a model of a Vivid shock, the current one, so it's got quite a big body on it, and similar to the X2 from the Fox. So I know that if I model my frames with these bigger shocks, that there's a good chance that they'll fit any shock on the market. So that was the approach with that. So once you get these parts into the frame as a frame of reference, both Shimano and SRAM have documents that lay out all the different interface specifications. So bottom bracket threads, brake caliper positions, shape of cranks, shape of the brake calipers, headset clearance, like all those sorts of things. They're all listed out. Shimano's is incredibly extensive, but can be hard to read at times. The SRAM one is actually presented really well, laid out, though it's at times it seems a little bit lacking in a few bits and pieces, but for the most part the information's there. So once you've got all that information together, it then becomes a bit of back and forth in terms of deciding on tubing size and wall thickness, and a whole bunch of other stuff. So that's when you start diving into what's available, like from Columbus, Reynolds, what's the other one, KVA, stainless tubing. So there is limits to what you can do. You can also use chromoly, 4130 chromoly, so you can get that in straight gauges, straight walled sections. And then you've got to start looking at things like rear dropouts, suspension pivot hardware, what your suspension pivot hardware is going to look like, what bearing sizes you want to use for these things, what else is there? And I've lost my train of thought. Yeah, so there's a lot of decisions to be made, and there's always a flow-on effect. So you might decide, oh, I'm going to use this particular size seat tube. Well, the problem with that is it going to fit the seat post that you want to use? With steel, it's actually quite limiting. It's hard to find the right, especially with my bikes. I've ended up using, and I'll show you in the next picture, 4130 straight gauge tube for my seat tubes, which means I've got some machining to do or to use a shim in the seat post, because Columbus and Reynolds don't make a seat tube to suit what I want to do with my bikes. So it's not a compromise, it just means you have to search further and you have to work harder at finding the right materials for what you're doing. So once you start then deciding your tubing sizes and your tubing shapes, all the bits and pieces, you have to then also decide, and one of the factors that just helps decide some of those things is your joining method. So a lot of builders use TIG welding. It's a very clean and a very efficient way of joining tubes. I didn't have access to TIG welding when I first started. I learnt to braze, and because of the lugs, it was a brazing job anyway, and I just naturally went over to Philip brazing the frames, everything, and even including on this latest bike, I still use one Philip braze joint. So it's a really great process for joining tubes and joining parts together. It's very strong when it's done well. It uses a lot less heat than TIG, and but there's nothing wrong with TIG either. So that they all have their own little pros and cons, and it'll come down to preference. Sometimes the materials will define the brazing that you're going to use, and also access to resources. Like, as I said, I didn't have access to TIG welding, so I had to make do with, not so much make do, but the option for me then was to use brazing. There are a few spots on the current Jester where I feel having it TIG welded would probably be a better process in a production sort of fabrication point of view. It's cleaner, it'll a lot less cleanup and a slightly different prep. So it's something I'll be investigating, but for the time being, the frame is basically joined together using probably you call it a reverse lug. So the printed part that I use goes inside the tube as opposed to in a lug. Normally the tube goes inside the part. So and that leads me on to the other part of the thing is these bikes, because of the non-traditional shapes, I've had to adopt using 3D printed sections of the frame, and as I've gotten into it, more and more of the bike has become 3D printed. So for instance, as you can see on the screen here, this is the bottom bracket section of my bike, and it actually encompasses all probably the hardest parts of the bike to make. So the main pivot, the joint around the bottom bracket, and the lower shock mount. This one has the anchor point for the integrated dropper from 8 pins, and as you can see, that's the piece that I end up with, and it's quite a large piece. And I mean, that would be impossible to make that from scratch, which is how I did the first couple of frames, was making that area of the frame from scratch, and it just took up a lot of time, and it's not conducive to being an efficient frame builder. So more and more of my bike is 3D printed, where it makes sense to use 3D printing, where I can get more efficient shapes and also have more consistency over the hard points, the connection points within the frame. So on this next view, you can see how that centerline drawing gets fleshed out into a full frame. So I've got all these shapes modeled as they need to be. These tubes are hollow, and why is that not doing that? Okay, let me change the. So as you can see, everything's hollow. I've got the guide tube for the dropper post on the inside. You can see the section that runs through the head tube. You can see the mounting point for the integrated steering dampener, and even the head, the badge is 3D printed. All the shapes needed are printed into the shape, into the head tube shape. The rocker's hollow. So all of that's put in as it's going to be fabricated, because you need to know exactly what the interface between the parts is going to be. So that takes quite a bit of time, and and there you end up with the frame shape. From there, I'll try and wrap this up a little bit quick. I've been here a while now. So from there, once I've finished with designing all the different parts and I'm happy with the bolts that I've used, the bearings and the shape and how everything's going together, and it looks good, I can pull each of the 3D printed parts out and create the right file that gets sent off to the 3D printer. They print the parts, they do some cleanup. With this one, I got the manufacturer to actually machine the threads in this time. I worked with them to work out a 3D printed blank, so to speak, that they had enough material to maintain some circularity. A few of you who have been watching before the previous one, this became overlies because of the heat involved, but we worked to figure out how that needed to be shaped prior to machining, and I got them to machine the threads with their CNC machine, and also the bearing seat on this one, and I can touch up the rest of it because that'll be easy enough. So once those parts are printed, they get sent to me. There's the tubes that I've ordered from Columbus. So these are double butted tubes, so they're thicker at the ends and a thinner wall in the middle. And then I will put it all together, basically. So that'll be the next video. I will jump into the workshop and I will go through each of the 3D printed parts. I'll show you the tubes and I'll explain more about the process of putting them together, and I'll show you some of the steps, and you'll see how the design work that I've put in here translates to the time saved in the workshop in putting them together. These frames go together quite quickly now, but I've spent many hundreds, if not thousands of hours here at the desk working out how to make that a possibility, and I'm pretty excited for where these have ended up, and the strength of the frame now is really high, which is really good, and still at a really competitive weight. So if you've got this far, I apologize. I have talked for quite some time now. I wanted to go in depth to show you what's involved with designing these bikes. I've actually skimmed over a lot of stuff that I was going to talk about, but I've realized now that it's a very long discussion to have, and I could break this video down into probably another 10 different smaller videos and get really in depth, and I might do that in the future, pick a particular point on the bike and talk about it and the challenges of those parts. But as I said, if you got this far, I really appreciate it. I'm going to do the whole like, share, subscribe thing. This will go up on YouTube as well as on the social, and if you have any questions, chuck it in the comments or even give me a message. I'm happy to tell you anything that I've learned about the frames and what I've been and what I do. I get messages from frame builders around the world asking questions, and it's awesome to be able to help those guys with their own projects and their own brand, and it's a really good community of craftsmen. So thanks again, and talk to you soon. Bye.